Hello. So let's start today with the square root as a first lecture. So considering a square root, it's a specific term in mathematics concerning a specific type of numbers and specific operation. Basically, when we talk about square root, we talk about multiplication in the background. So before we go into the square root itself, let's start with something a little bit, a little introduction to all of it, with, for example like this: a squared equals to 100. So 100 is a number. It's not just any number, it's a positive number. And I at the moment want to look what number squared gives us 100. So there are two possibilities. It's either going to be 10 for a, because a times a, or 10 times 10 gives us 100. But there are other combo as a possibility, and this is if we look at minus 10. Minus 10 times minus 10 is going to give us also 100. So we have two possibilities. Now, considering square root is going to be this here part. So 10 is going to be square root of 100. This is the idea. So this is a square root. And 100 is a positive number. Now, of course, minus 10 is also a specific number, but I'm not going to talk about him now here because I want to just concentrate on the square root. Now, let's define the square root using this here example. Now, the definition of a square root, and this is important part, is that square root of a positive, it's important when we talk about positive number, let's call it x. Now this is going to be the positive number x. So we are looking at the square root of x. Now instead of squaring the 10, I'm going backwards. So from 100, I want to get to 10. I want to get to the root, the idea. So square root of a positive number x is also positive number. So it's positive number, which we define as square root of x. This is the way we write it down, the square root of x. Now, this is not the end of the definition. The definition also says where this square root of x, if I square it, if I do this here operation, so if I use square root of x and now I square it, we are going to get the number x, the positive number x. Now, when we talk about all of this, we're talking about real numbers. Only in real numbers this applies. Now, of course, in the second lesson today, we're going to expand the whole thing about real numbers into a new set, which we always also have to apply the root to. But at the moment, I'm just looking at the square root for real numbers, and this is its definition. Now let's go a little bit more about this definition so that we understand everything that's going on. So, square root of a positive number x. So let's say that x is 100. So this is the x. Is going to be positive number. We got here a positive number. We also got a negative number, but this is why I said I'm only looking at a positive number. So this is, I can also write down, this is the square root of x. This is the square root of x. Where if I use the square root of x, aka 10, square it, I'm going to get the 100. Now there are some consequences considering the root itself. First of all, root has to be a positive number. Second thing is that the x itself, this is the root of a positive number, so the x inside of it, this is the x inside, so this is the 100. So if I look at it like this, square root of 100. I can now apply it. So square root of 100 will give us the 10. Okay? Let's use another example. For example, square root of 25 is going to be 5. Square root of 49 is going to be 7. Now look at what we have. Inside of the root, always a positive number. Outside of the root, always a positive number. So this is where the positivity kicks in. Another thing is, if you're not certain how to do it, you can use the calculator and determine what's going on. For example, things get complicated if you look at square root of 7. Now, the examples before here were always of a number that is a complete square. We call it a complete square because if you use its root is integer, or more specifically natural number. So if the root is a natural number, if you square that root, the number that you get, this here x or this here square as a result, is going to be called like I said earlier. 7 on another hand is not going to be like 125 or 49 because it's not made out of a root that is natural. What you get is, using the calculator in this case, then, is that square root of 7 is going to be 2.645751311, etc. It continues on. Depending on the calculator that you use, it may go on or it may stop somewhere earlier. But before I go into the last idea here, I just wanted to mention, like, yeah, you can use a calculator whenever you can. You don't have to know all of this by heart. You can use the calculator, of course. But what I wanted to talk about is the property and some consequences considering the roots themselves. Now let's talk about those things. So first of all, inside of the root, it always has to be a positive number. So let's determine it in considering all of this together. 100 is a positive, 25 is positive, 49 is positive, and 7 is positive. So inside of the root, so if I use this whole term, x has to be greater than 0. This is the idea. Now, one specific number I haven't mentioned in all of this, and that is 0. And what is going on with it? If you square root a 0, the result is going to give you 0. So still works perfectly fine. So we can add here that it can be also equal to 0, the x. So whatever is inside of the root, this is the inside of the root, it always has to be greater or equal to 0. Once more, square root of a positive number x. This is the definition of a positive number x. This means that inside of the root has to be the positive number x. Specifically, also, it can be 0. If we look at the negative specter of the numbers, well, this is going to lead to the following lecture. Not gonna delve into it yet. So these are some properties of the square root itself. Easy enough. I'm not going to complicate stuff. Let's keep it simple enough. So, one more thing I have to talk about is this here example with square root of 7. So, 2.645751311, etc. When it is squared, it's going to give us number 7. So, if I square this here number, I'm going to get 7. This is the opposite way of looking at things. Now, this here number is a specific number in mathematics. It has its own name. This type of number, it has its own type, is first of all infinite. It's infinite decimals. Infinite decimal number. Without repeating pattern. So infinite decimal number without any pattern inside. Yes, for example, we see that ones appear multiple times, but they're not part of any specific pattern. So you don't have a pattern. This is gonna go to infinity, never going to stop, never become, so to say, number that's gonna have repeating decimal parts or the patterns, so 1 2 3 1 2 3 1 2 3 as an example. And this type of number that is infinite, that has infinite decimals, is and also no pattern in the side of it, is going to be called irrational number. Irrational number. Why is this important? Well, now I did show you some specific square roots, which result in natural numbers, but most of them, infinite number of them, are going to be like square root of 7. Simple thing can be what you can look at: square root of 2, square root of 3, square root of 5, square root of 6, square root of 7, square root of 8, square root of 10, square root of 11, etc., etc., etc. They all will be this infinite decimal number without repeating pattern, and they're all going to be called irrational numbers. Why is this important? Because the second part of this lesson is going to concentrate around irrational equations. So this is going to be the application of the square root itself, and the term when you work with a square root is going to be called irrational. So let's write another title here: irrational equations. Irrational equations. Now, of course, I'm going to separate these two parts. So this was the idea, the definition, the basics of square root. Now let's talk about equations themselves. Let's start with something simple. Let's start with task 1. In task 1, I'm going to show you a couple of examples. These are the ideas. I'm going to give you, of course, when we meet also the practice tasks, which are going to be based upon the tasks that I'm going to show you here, in examples here, so you can also try it out yourself. So let's start with task 1a, and in this here task, let's start simple enough. Square root of x equals 6. So this is a irrational equation. Why? Because the unknown, the x in this here case, it appears inside of the root. So this here whole form is going to be called irrational because, well, it may or may not be natural number. Well, square root of x equals to 6, so the right side is natural, so it will be a natural, but it doesn't matter. The idea is, because of most of the roots are going to be irrational numbers, immediately when you see something like square root of x, we say it's irrational equation because of that. So how do we solve this? Simple enough, nothing fancy. We want to get rid of the root. How I'm going to get rid of the root? I'm going to apply the definition of square root. This means if I square the root, I'm going to just be left with what is inside of it. So let's square it. Now I'm going to do an extra step. I would encourage you to do the same. Don't skip this step. It will help you out specifically for this week. So let's use it like this. So what the square does in this here set. So left side squared, right side squared. So let's start with the left side. Square root of x squared is equal to 6 squared. I'm not going to apply the square yet. I'm going to do it in the next or following step. So I'm applying the definition. Square root of x squared equals to x. So this means that we have x. Basically what happens is that a root and a square cancel each other out. Meanwhile, on the right side, as it's separate form, so we are looking at left as one thing, right as another thing. So if you look at the right side, 6 squared is going to give us 36. Now this was simple enough thing where we see that x is equal to 36. Done. Now one thing I haven't talked about, and I should have talked about at the beginning, but doesn't matter. I've done this example because we usually skip it, so let's not do it here. I have to still apply the formal part that the x has to be positive number. So this here means that whatever is inside of the root, this means here x, has to be greater or equal to 0. If we get something that is not greater or equal to 0, then the result that we got is not actually the result of this here equation. Now 36 is greater or equal to 0, so everything is fine. 36 is the solution to all of this. Now why is this important? I'm not going to give you the examples where things won't work. We are keeping things simple. But let's still learn that when we ever have irrational equation, and when we have to deal with irrational equation, that we still have to use so-called condition. So this green part that I've written down is called condition. So if the result passes the condition, it is the result of the equation. If it doesn't pass the condition, well, this equation doesn't have to have the result, or maybe we've made a mistake during the solving part and we need to go back a step and see what we've done wrong. So let's look at the B task. Now I'm gonna expand things a little bit. So now instead of square root of x, we're going to look at the square root of 3x minus 1, and let's say it is equal to 5. Now inside of the root, we don't have to be given just the x. We can be given an expression. So expression in this here sense is that inside of the root is 3x minus 1. But when I look at the composition of the A task and B task, what we have is the following. In both A and B task, we have root on one side of something, and it is equal to a specific number on the other side. Now, if we used in the task A the method where we squared everything and then got the solution, why not try it also in this here task? But before I go into it, let's write down the condition. Now, condition in this here task is going to be the 3x minus 1. So everything inside of the root has to be greater or equal to 0. Please do not forget that in the tasks for practice or tomorrow when I'm going to assess what you've learned considering this. Now, this is not the ending. I want to simplify it. I want to see what's going on with the x itself. So what this means, unknown stays on the one side, everything else has to be put on the other side. So let's do it like this. So 3x is greater or equal to 1. Minus 1 changes the side, also changes the sign. Last thing is I'm going to do is I'm going to divide everything with 3, and x is greater or equal to 1 over 3. So if we get a number that is greater or equal to 1 over 3 as a solution to this equation, this number is going to be the solution of the equation. Now, once I've done this, I can go back into the method, and since I've already talked about the method now, I'm just going to apply it. So we have a root on one side equals to a number on the other side. Let's square the equation. Now, what happens is the following. We have to square 3x minus 1, square root of 3x minus 1, and on the right side, we have to square the 5. Let's write it down. Let's write this down. Let's not skip this part. Now, I'm applying the definition of a square root. If I square it, I'm going to be left with everything that is inside of it. So 3x minus 1 is the left part, and the right part is going to be 25. Now, what we got now is the linear equation, something that we've learned in the first grade, something that you also should have been learning back in the primary school or wherever else, and it shouldn't be anything new. So let's solve it till the end. So first thing that I'm going to do is I'm going to add 1 to both sides. This means that 3x is going to be equal to 26 because minus 1 and 1 is going to cancel each other. 25 plus 1 is going to give us 26. And last step is divide everything with 3, and x is going to be 26 over 3. Well, 26 over 3 is far, far, far into the plus side and greater than 1 over 3. So this is going to be the solution of the given equation. And we are done. Now I'm going to show you one more example in this here task. Let's go with the C example. And here I'm going to change the order of things a little bit. So what are we going to do here is that square root of 5 minus x is going to be a square root, the irrational, so to say, part. Then we are going to subtract it with 2 and say it is all equal to 0. This is the thing that's going on now. Now, what is the idea behind this task? Well, it's a little bit more complicated version of task before. Unlike task before, B and A, task C has everything on one side equal to 0 or another number, I don't care. Now we do not want to square this immediately. Why? Because if you square everything here, what is going to be the following thing? And I'm going to write it down like this, and that this is not going to be the correct path yet. So if I square it, you're going to get on the left side square root of 5 minus x minus 2, everything squared is equal to 0 squared. This is what you're going to get. Now the issue is with that because the following step. You have to square everything. Now there is a formula you use in mathematics where you have a square of a binomial, or two numbers that are either subtracted or added to one another. So either a sum or subtraction. So this is the formula. A plus minus b squared is equal to, I'm going to write it down beneath, a squared plus minus 2ab plus b squared. So this is the formula that you use for square binomial. Now what happens in the following step is that a squared is, let's say, a is the square root of 5 minus x and b is going to be number 2. So first, okay, we get square root of 5 minus x squared, nothing worrying. So we basically got rid of the root and we are left with 5 minus x. But in the middle part is where things don't work out as they should. Because we're going to get minus 2 times the a, square root of 5 minus x, and times the b, which is 2. So 4 times square root of 5 minus x. And the thing that we got is we didn't get rid of the root. And we want to get rid of the root. Like in this example A and B, we got rid of the root. That's the idea. So what we have to do at the beginning, of course, after we assess the condition, is order things so that root is alone on one side and everything else is on another side. So let's go with that after we solve the condition. So the condition is everything inside of the root has to be greater or equal to 0. So 5 minus x has to be greater or equal to 0. Minus x is greater or equal to minus 5. 5 changed sides and also changed the sign. Now one last thing is I want to see what's going on with the x. So I have to divide everything or multiply everything with minus 1. Now you should not forget, when you multiply or divide a number with a negative number, the inequality will turn around. So what you're going to get is that x is less or equal to 5. This is what you're going to get. Why is this so? Let me show you also with an example. I'm going to write it down here. So if 2 is less than 5, it should be. If I multiply everything with minus 1, what we're going to get is minus 2 and minus 5. Now, who's greater or what's greater? Minus 2 is greater than minus 5. This is the logical idea. So if you multiply or divide with minus 1, the inequality will turn around when you apply it. Okay, so let's continue on. Let's go back to the solving part itself. So for the solving part itself, now what we have to do is that minus 2 has to get on the other side. So square root of 5 minus x is equal to 2. Now we've got a situation similar to task B. Square this. So square root of 5 minus x squared is going to be equal to 2 squared. Square and root are going to cancel each other out. So 5 minus x equals to 4. I'm going to subtract everything with 5. So minus x is equal to minus 1. 4 minus 5 is going to be equal to minus 1. one last step. I'm going to multiply in this here case, for example, with -1. So x is equal to 1. Is 1 less than 5? It is. We got the right solution. Everything is okay, and we are done. Now, these were 3 simple examples that I'm going to give you practice tasks for after the lesson. Also, I'm going to show you just one more example or one more task which is also important, and I want to talk about it a little bit more. And this is the following task, task 2. So let's go with that. Now, task 2, unlike task 1, all the examples in task 1, has 2 roots in equation. So what this means is the following. Square root of 5x plus 1 minus another square root of 2x plus 3 equals to 0. So this is the equation. Now, the approach to solving this equation is going to be the same as in task 1c, where we are going to put roots on opposite sides, square it, everything, and then get the solution. Before going to the solving part, now we have to talk about the condition. There's not going to be just one. There's going to be 2 conditions because we have 2 square roots in this task. So one of the conditions is going to be that 5x plus 1 has to be greater or equal to 0. So this is from the first root. Another condition is that 2x plus 3 has to be greater or equal to 0. Now, since both of the conditions have to work, and the result has to pass both of them, this means that they are connected with AND. They both have to work. Now we are going to solve them separately. So 5x is greater or equal to -1. X is greater or equal to -1 over 5, divided with 5, of course. But while the second one is going to be 2x is greater or equal to -3, and x is greater or equal to -3 over 2, divided by 2. Now, the result has to be basically greater or equal to -5 and greater and equal to -3 over 2. So if it passes both of these tests or conditions, then it's the result of the given equation. Let's go into the solving part. The solving part now, okay, I've said we're going to divide each root on its own side or keep it there. So the first one I'm going to leave on left side, 5x plus 1. Meantime, the other one is going to be on the right side, and it's going to result in 2x plus 3. What happened is I have actually added square root of 2x plus 3 to both sides. So on the left side it got cancelled out, while on the right side 0 plus square root of 2x plus 3 is going to give us this. Now, once we've gotten a situation like this, simple enough, we just square it. Now we square the left side, we square the right side. Let's write it down. So 5x plus 1, everything squared, is equal to square root of 2x plus 3, everything squared. Square and root on both sides are going to cancel each other out. So we are left with 5x plus 1 equals to 2x plus 3. Linear equation, we can solve it. Group unknowns on one side, everything that is known on the other side. So I'm going to, for example, subtract with 2x. So 5x minus 2x is going to be 3x plus 1 equals to 3. And one more thing, I'm going to subtract with 1. So 3x is equal to 2 divided by 3, of course, and x is equal to 2 over 3. Now let's check if this is the actual solution. 3 over 2 is definitely greater than -1 over 5. And it is also greater than -3 over 5 because these are both negative numbers. Meantime, 2 over 3 is a positive number. If you're not 100% sure, you can always use the decimal values. Use the calculator to transform this into the decimal form and the result also in the decimal form and see who's greater. So you can also check it out like that. It passes both tests. It is the solution of the given equation. So 4 altogether examples of the tasks themselves. Task 2 is the most complicated one I'm going to ask of you, while task 1, simple enough, ideas, go through them one more time. Practice tasks are going to be given to you where you can also try it out. If you have any questions, you know how to get in touch. Catch you in the next video.